Minor Planet Center Data Processing System.
Thank you. So, as many people have already talked about the Minor Planet Center and the data being reported to it, we are the world's clearinghouse for minor planet astrometry and photometry. I want to talk to you about, give you a status report about the Minor Planet Center and talk about the things that we're doing. So as everybody knows, we're motivated by the same congressional mandate to find 90% of the PHAs with diameters larger than 140 meters. And that's, of course, supported by increasing funding, but this is really what drives us here. And we're really a service mission to help all the world's NEO surveys do their job. So this is where the observations get reported, not only to the discovery observations, but the follow-up observations. And our task is to aggregate those data and help process them and serve them back to the community so that they can understand what's been discovered and guide their follow-up processes. You've seen this before. The data come in from all kinds of different sites. This is actually unrepresentative. There's quite a bit of data that, vast amounts of the sky are covered every night. We are getting something like 100,000 observations reported to us every night. And they're coming in from a variety of sources, but it's mostly from a small number of large surveys. The data is primarily coming from those, but that's not to say that there's many sources that are providing valuable data to the MPC and to the community. And that volume of data is increasing year by year. We're also motivated by planning ahead in the next decade to be ready for the avalanche of data that's will be coming from the Large Synoptic Survey Telescope and from missions like NeoCam. But I want to emphasize that these are not the only big games in town. The current surveys, they're all expanding. Other surveys like ZTF are coming online. So the increase in data you can see in the charts is pretty much continuous. It's been happening for a very long time. There are many sources, and we have to keep up with all of them. So we're hosted by the Smithsonian Astrophysical Observatory at the Center for Astrophysics in Cambridge, Massachusetts. And we operate, our authority comes from the IAU. We're now a functional subnode of the Small Bodies Node at University of Maryland here. We've been 100% funded by NASA since 2008. Our money comes through a cooperative agreement through University of Maryland through the Small Bodies Node. We're growing to 10 FTEs. And it takes we'll take all of those people to keep up with the data. This is just a slide to show where we fit into the Planetary Defense Coordination Office and the NEO Observation Program, and then our staff. Again, so our responsibilities, I'll say again, we're basically getting 2 million new observations per month. Our database holds almost 2 million observations. Most of those have come in the last few years. Our real responsibility is to help process these data in real time to separate the NEO candidates from a stream of mostly main belt asteroids and maintain what we call the NEO confirmation page. A lot of the people in the room know really what this is, but that's where you really go to get the information about NEOs, where you go get that information and figure out, help prioritize. So we're really providing sort of primary data for a lot of different people. We're, tasked warn for closely approaching objects and provide a database of all of their orbits. And there's something like 800,000 objects that have pretty reasonable orbits. And we archive all our data with the PDFs. So those of you who haven't seen our website, it looks like something like this. It will be upgraded. Just to give you a sense of the typical sequence of events, astrometry comes in, we carry out sanity checks. Basically, were the observations, are they reported from a site such that would be during the nighttime? Sometimes that doesn't always happen, or various, formatting checks. If those pass, we archive the data. We check to see, is this something we already know about? That's one of the very first checks. Is it a known object, real or artificial? And if we can identify that, we quickly pull those out of the data stream because it's not a priority. If the object is flagged as a possible NEO, then we'll we will set that aside, and I'll tell you a little bit more. In fact, Peter Barris will tell you a lot more about how the community identifies what's a potential NEO. And then otherwise it gets into the isolated tracklet file. So I'm going to just zoom through this because I don't have a lot of time. So NEO confirmation page just basically tabulates all of these objects, and people can pull observations or targets off of that page. You can do that programmatically as well. I will skip the isolated tracklet file. That is really like where things end up if we don't know, if we haven't identified this is known or that this is in NEO. There's a gold mine of observations that can be linked. And then the final thing is once an object is, enough observations have arrived that we can confirm its orbit, the results come out in a minor planet electronic circular or MPEC. So what are we focusing on? One of the big things is that we are migrating from a legacy system into something modern. We have a hybrid VMS Linux system, and we really have to get off of VMS. And there's several reasons drivers for that. Yeah, you chuckle because there's enough people in this room that understand that. I mean, anybody raise your hand if you've dealt with a legacy system. All right, there's a lot of love in the room. Thank you. So it's a hard task. And the problem is that you just don't have enough staff knowledge. There aren't very many people who can really deal with VMS anymore, who can actually maintain an argument about why we need to get off of that. But we're doing it, and we're steadily getting things into Linux, into modern systems. We have to not only have the staff knowledge, but we need to have a much faster system to keep up with a factor of 10 to 100 flow in data. But it's happening. We are also using a new data format, ADES, and this is something spearheaded by Steve Chesley now almost 4 years ago, to move off of the old 80-character format into something that'll support higher precision, a lot more fields, astrometric uncertainties, and quite a bit more. And the format itself is not the key thing. It's the content of the data that's really the key. So this is an important transformation for the community and something that's tough. Another advancement is we're doing a much better job with uncertainty maps. This is something that was really spearheaded by Matt Payne and Peter Barris, using a Markov chain Monte Carlo approach to the observations we have, so that our predictions of where things should be in the sky to support follow-up are much better, are well posed statistically. They match what you see with Scout. This is something that I'm really pleased with. We're also implementing some novel techniques for linking. So if you have a lot of data, one of the unfortunate things about asteroid data is they don't typically come with a name tag, right? You don't know which of these dots go with the other dots, unless it's something that you already have a well-established orbit for. The brute force approaches is to try to match everything with everything else, and the computational scaling for that is really, really difficult. We now have newer approaches that scale as n log n. This is a big advance. It's something that allows us to pull a lot of, connect a lot of data over wide spans of time, much more than we could before. Another example is a faster MP checker. So for those of you who don't know, MP checker is a service that the MPC provides, where if you tell us where you're observing from, when you're observing, and what your field of view is, it'll pop up all of the minor planets that are in that field of view. It is presently slow, but it's something that is used by, actually, this will surprise you, mostly used by the supernova community, because they want to know what asteroid popped in front of their galaxy and looks like a supernova. And so you can imagine they get grumpy if that's slow. So we are making this much, much faster. We're also collecting pointing information. If you tell us where you looked, the moment you began that exposure or finished that exposure, we can serve that out to the community to let everybody else know where you looked right away. This is valuable for lots of different reasons. One thing that we're changing is we had established a format, and we're basically a JSON format with all this information. We realized later it's probably just easier if you just send us your FITS headers for your exposures. Lastly, we have an MPC users group, and I owe a lot to these people because they really keep us busy to try to improve MPC services. We meet twice a year, once at the MPC and once at a user site, to get this input to keep us moving in the right direction. I'll say that the MPC is hiring. Take a look at the SAO's employment pages. Keep an eye out for advertisements. They come out pretty regularly. This is a community that there should be a lot of interest in this room. And so in summary, the Minor Planet Center is playing this key role as the central clearinghouse in the search for NEOs. We're in the midst of this challenging legacy migration project. We're implementing lots of new algorithmic approaches, and we're ready for an avalanche of data. So thanks.
Gonzalo has a question, I believe.
Well, rather than a question, it's a suggestion. Since you are doing some improvements, I suggest that you include the orbital elements error, the uncertainties in the orbital element determinations in your publications, because, I mean, I know that you publish this quality code that is some shrinking of the error, but it could be useful for us to analyze the errors and the covariant matrix in particular.
Yeah, you're preaching to the choir. I totally agree with you. We'll do a better job with that.
Another quick question, if there is one. Okay, thank you. And